This is problem 3 from the winter 2015 final exam. It's about a mass m with some initial velocity that hits a bigger mass of 2m that is initially at rest. After the collision, 1 and 2 will take the paths drawn here, and the point of this exercise is that if they give you information about 1, its speed and direction, then you should be able to find the information about 2, specifically the x and y components and the angle from the x-axis. To accomplish this goal, we recognize that it is a conservation of momentum problem since it is a collision. Momentum is a vector, so I have to deal with both x and y. So the first mass is moving completely horizontal, so its initial momentum in the x is just m times its speed. The second mass is at rest, so initial momentum is 0. In the final, the x component of the momentum will just be 2m times the x component of the velocity, v2x, and we'll leave it this way because we want to solve for it. Then we write the x component of the momentum for the first mass, mv1 times cosine of 53 degrees. So after this, we just solve for the x component of v2. And the toughest part of this was really just making sure we got the x components of initial and final correct for both bodies. At the end, we get about 1.3 meters per second. For the y, initially, mass 1 is moving, but it is completely in the x, so there's no y component. The second one is not moving, so it's 0. So my initial momentum is 0, and I should have the same for final momentum. So I write down the y component of 2 final and 1. And this tells me that the y component of the velocity final for the second mass is just the following, which when we plug in all the numbers, we just get 1.6 meters per second. Then we have the y component and the x component, then we use tangent of theta to find the angle from the x-axis, plug in the numbers, and we get either 51 degrees or 231 degrees. Since both of these angles have the same tangent, but since I want both x and y to be positive, then I have to choose 51 degrees. The next part of the problem is about impulse, and it asks you to find the impulse that both objects feel during the collision. And the important concept here is that impulse gives you the change in momentum. So you want to find the final momentum of this mass and its initial momentum. We know the initial momentum of 2m was 0 since we're staying at rest. So we plug in all the numbers and just find what is that vector. Its x component will be its mass times its x component of the velocity. Its y component will be the mass times the y component of the velocity. And then you can find the magnitude or the angle or whichever. Then the next important concept is that the impulse that 1 puts on 2 has the same magnitude as the one that 2 puts on 1, but obviously in the opposite direction due to Newton's third law. Alright, so quick recap. We have a collision, and both dimensions x and y are involved. First, a mass coming in and hitting something at rest, and then the two going off at different angles is shown. So it is a collision problem, therefore it's a conservation of momentum exercise, and they want you to find the x and y components of the velocity of 2 and that angle it makes with the x-axis. So set up the initial and final momentums in the x, making sure you get all the x components right for both objects, and then solve for the x component of the velocity. Then do the same for the y, making sure you get the right components, solve for the y component of the velocity, use tangent of theta to find that angle, make sure you pick the angle that gives you positives y and x components, and then remember that the impulse is equal to the change in momentum, so write down your final momentum, and remember the initial momentum was 0. And then remember that if you find the impulse on 2m, then you know the impulse on the other one, but the other way. And yes, it's a lot to remember, lots of different concepts, so that's what makes this problem useful for learning. And I hope that this video was also useful for you to understand it. All right, have a good one.